It's kind of cool to think that the future of clinical care could be that we hear before we see. At Google Research, we developed health acoustics representations, otherwise known as HEAR, which is a foundation model. With HEAR, we hope that researchers will be able to discover new acoustic biomarkers a lot faster. I grew up in India where tuberculosis is killing about as many people each year as COVID did in 2020. And compared to blood tests and imaging, sound is by far the most accessible piece of information that we can get about a person. In places where access to advanced medical resources is scarce, we can imagine a future where a healthcare professional with a machine learning model on a phone can collect a sample of your sound and inform clinical care. This is not the first time somebody has applied machine learning to come up with acoustic biomarkers. COVID spurred a lot of innovation into this space, with researchers trying to pick up diagnosis for COVID and other health conditions like tuberculosis by just analyzing the cough sound, and the results were pretty promising. But it was very expensive and slow to discover these biomarkers. With HEAR, we make that process a lot faster and more efficient. The healthcare challenge here is actually a dataset challenge. At Google Research, we have a concentration of the best machine learning specialists in the world, and we also have infrastructure that's required to train a model of this size. To build HEAR, we needed millions of examples of sounds like cough and breathing sounds. So we identified those from over 3 billion videos using acoustic event detector. We then used self-supervised learning to generate low-dimensional representations, which were optimized to extract the most salient information about health tasks. With highly optimized low-dimensional representations of their data, researchers can discover new biomarkers with a lot less compute and with smaller data sets. Bless you. I think that was just, I knew it was coming too soon. We trained simple linear probes to evaluate HEAR on about 33 tasks from across 6 datasets. These included things like picking up chest X-ray findings from cough sounds, picking up tuberculosis and COVID, and we saw that HEAR performed well across all of these tasks. Having access to a robust foundation model like HEAR will let researchers tinker with their ideas a lot faster, with lots of cost savings in compute resources and the time required to come up with a new model. I'm excited for the possibility of what kind of findings that were previously visible can now be heard.